Hi, I'm Nikno Nadia Fariza, as a representative from this group, which consists of Yasmi Firuzana, Muhammad Syarif, and Felicia Lirik. So, in this video, our group will show the simple pendulum experiment.
The objectives of this experiment are to study simple harmonic motion, to study the motion of a simple pendulum, to learn the definition of period, frequency, and amplitude, to learn the relationships between period, frequency, amplitude, and length of a simple pendulum, and to determine the acceleration due to gravity using the theory, results, and analysis from the experiment.
These are the materials used in the experiment. For part 1, swing the pendulum at the amplitude of 5 degrees and record the total time taken of the pendulum for 50 oscillations. Repeat the experiment with the length increased by 10 cm. And for part 2, the steps are: set the length of the pendulum to 30 cm. Swing the pendulum at the amplitude of 5 degrees and record the total time for 50 oscillations. Repeat the experiment with different amplitude.
Here's the tabulation data obtained from part 1 of the experiment. And this one is the results obtained from part 2 of the experiment.
As conclusions, from the above data and results, we have concluded that there is an impact on the frequency of a simple pendulum if changes its length, and there is no effect on the change of amplitude. This can conclude that the equations of the period of a pendulum is accurate because the angle is not included in the equation. Therefore, it does not affect the period of the pendulum. So, to be very precise, there is a slight effect on the change in the amplitude, but it is quite negligible. Do not consider them.
Hello everybody, in this video we will show the magical created by refraction.
The main objectives of this experiment is to prove the laws of refraction of light. By proving the laws of refraction of light, we'll be going to determine the refractive index of water and oil.
First step, draw the boundary of the beaker with a pencil and then mark as PQRS. Next, on the line PQ, draw a normal to the point O. Mark a 30-degree angle. Then place the beaker and fix 2 pins vertically on the board. After put the beaker on its boundary, look from the other side of RS and fix 2 more pins in such a way that all the 4 pins appear in a straight line. Then remove the pin one by one. Make a line to join the 2 points and draw a normal on RS. Observe the angle of emergence and angle of refraction.
Next, this is the findings from our experiment.
This is the discussion for the experiment. The main point to be highlighted is when a ray of light suffers minimum deviation through a different medium, angle of incidence is equal to the angle of emergence. Using a formula stated, the refractive index has been calculated. The refractive index of oil is greater than water. That means that the speed of light in oil is less than in water. The phase velocity is low in a material due to electric field disturbance, which is proportional to the electric susceptibility of that medium.
As conclusion, the results shown had structurally support the very concept of the law of refraction. with the refracted angle and refractive index for water and oil being 22 degree and 1.33 and 20 degree and 1.46 respectively. Therefore, from the experiment, it is safe to assume that the incident ray and the normal at the point of incident and the refracted ray are in the same plane of the paper, thus verifying the laws of refraction.